Diesel Engine Maintenance Guide. Maintenance cost, as defined by normal accounting procedures, are normally a major portion of the total operating costs in most plants. Evaluation indicates that between 1/3 of these maintenance expenses are wasted through ineffective maintenance management methods. The dominant reason for this ineffective use of maintenance expenditures is the lack of actual data that quantifies when and what kind of maintenance is needed to maintain, repair or facility. Typically because maintenance organizations do not track equipment performance, maintenance task performed, failure history or any of the other data that could and should be used to plan and schedule tasks that would prevent assets and reduce their life cycle cost deterioration process. What are the types of maintenance? There are two types of maintenance management approach. In most of our plant, either run-to-failure approach or preventive maintenance approach. What is run-to-failure approach? The logic of run-to-failure management is simple and straightforward. When a machine breaks down, fix it. This is the don't-fix-it method of maintaining plant machinery has been a major part of plant maintenance operation since the first manufacturing plant was built on the surface, which sounds reasonable. The plant using run-to-failure management does not spend any money on maintenance until a machine or systems fails to operate. Run-to-failure is a reactive management technique that waits for the machine or equipment failure before any maintenance action is taken. It is also the most expensive method of maintenance management. However, in almost all instances, plants perform basic preventive tasks, lubrication, machine adjustment and other adjustment, even in run-to-failure environment. The major expenses associated with this type of maintenance management are: 1. High spare parts inventory cost. 2. High overtime labor costs. 3. High machine downtime and 4. Low productivity availability. What is preventive maintenance? There are many definitions of preventive maintenance, but all of these management programs are time-driven. In other words, maintenance tasks are based on elapsed time or running hours of operation that are based on statistical or historical data for specific types of plant equipment. Statistical life or MTF mean time to failure followed the normal machine life period. The probability of failure increases sharply with elapsed time or hours of operation. In preventive maintenance management, machine inspections, lubrication, repairs or rebuilds are scheduled based on MTF statistics. The common denominator for all of these preventive maintenance programs is scheduling guidelines. All preventive maintenance management programs assume the machine will degrade within the statistical time frame. What is the nature of preventive maintenance? Nature of preventive maintenance. Preventive. The nature of servicing the generator sets calls for actions which will prevent the major repair work. These actions can be performed at an operator level, and can usually be categorized into 1. Adjusting, 2. Servicing and 3. Treatment. Adjusting. Adjusting is the action of correcting misalignments, testing for the proper set points, calibrating and tightening loose components. Servicing. Servicing is the action of maintaining the proper amount levels of lubricating grease, oil, coolant, fuel and others. Servicing also encompasses replacing or cleaning filters elements, as well as performing minor repair work. An example of minor mechanical repair work is replacing the gasket or seal, etc. An example of minor electrical repair work is replacing the light bulb or fuse. Other minor repair work can be accomplished by operator-level personnel and by use of the manual. Major mechanical repair work should be performed by an authorized mechanic as a precaution against damaging the equipment or injuring personnel. Likewise, major electrical or electronic repair work should be performed by authorized technicians. Maintenance Guide. Schedule of maintenance. A service standard for generator sets. 1. Review the previous service reports, or if an operator is available, check it. There has been any operation issues with the unit and address as required. 2. An oil sample must be taken prior to the engine being stopped for service. 3. Isolate the batteries before commencing work. 4. Ensure set is isolated electrically and engine is up to operating temperature. Maintenance Guide. Schedule of maintenance. 1. Change engine oil. Only drain cold if engine cannot be run up to the temperature for some extreme reason. 2. Change the oil filters, main and bypass. Remove and clean the centrifugal oil cleaner and refit. 3. Change the fuel filters, rackover and secondary as required. If necessary, remove the rackover and clean. 4. Check the fuel tank for water and drain down as required. 5. Check/change air intake filters and rear doors. 6. Check/change main engine air filter and safety element as required. 7. Check/change main alternator air intake filter if applicable. 8. Check/change coolant filters at 3000 hours interval if applicable. 8. Renew all filter replacement date stickers onto each unit. C9. Check the tension and condition of battery charging alternator drive belt. Read tension or renew as required. 10. Check the tension and condition of battery charging alternator drive belt. Read tension or renew as required. 11. Check the governor oil, lubricate fuel linkage and check condition of rose bearing if applicable. 12. Check the coolant system top tank level. 13. Check and log the antifreeze protection level 50/50 mix. 14. Check and log the DCA levels. Cummins only 0.8 units/liters. 15. Check and log the coolant pH value range 5.5 to 9.0. schedule of maintenance. A service standard for generator sets continuation 1. On system where the pH value fails to meet the above limits, the system should be drained and refilled with pre-mixed coolant. 2. Check the radiator fan motor and engine space fan motor. 3. Check all guards and safety notices. 4. Check all batteries, battery isolator, electrolyte level, terminals and cables. 5. Check the panel-mounted battery charging system for operation and log voltage. 6. Check all panel meters, switches and connection. 7. Check the operation of all shutdowns. 8. Check all earth studs, load cable terminals and terminal safety covers. 9. Check the rain cap whether it is operational. If not, replace it. 10. Carry out a visual check for fuel/oil/water leaks and rectify as necessary. 11. Check all AC and DC container lighting. 12. Fill in the last service sticker and attach to the panel. 13. Run setup and check pressures, temperature and DC alternator function log voltage. 14. Steam clean the generator inside and out where possible. Containerized Gansett. 15. Attach a complete service report and update. What about comprehensive preventive maintenance? A predictive maintenance method. Predictive maintenance is not the vibration monitoring, thermal imaging or lubricating analysis or any other form of marketed predictive maintenance tools. Rather a philosophy or attitude that simply stated the uses the actual operating condition of a planned equipment. A comprehensive predictive maintenance management program utilizes a combination of the most cost-effective tools. By obtaining the actual operating condition of critical plant system and based on this accurate data and schedule all maintenance activities on an as-needed basis. Generator Comprehensive Maintenance Guide. A predictive maintenance program can minimize unscheduled breakdowns of all electrical and mechanical equipment in the plant and ensure that the repair equipment is in acceptable condition. The program can also identify the problem before they become serious. Most problems can be minimized if they are detected and repaired early. Normal mechanical failure modes degrade at a speed directly proportional to their severity. If the problem detected early, major repair can be prevented. In most instances by means of diagnostic method. What are the benefits? Effective use of preventive maintenance, including predictive technologies, will eliminate much of the 33% to 50% of maintenance expenditures that are wasted by most of the plant. 1. Elimination of unscheduled downtime caused by the equipment or system failures. 2. Increase manpower utilization. 3. Reduction of maintenance expenditures. 4. Increase useful life. Please like, share, and subscribe to my YouTube channel. Thank you.